Hey, what's up everybody? My name is Moss, and in this video, I want to introduce you to tail sampling. I'll briefly introduce you to what tail sampling is, and then I'll show you how to configure some basic tail sampling policies in the OpenTelemetry Collector. And sampling is definitely useful if you have a very high volume of requests coming into your application and a large amount of telemetry data being generated from that. Let's say you have like 1 million requests per hour coming into your application, and so you have like 1 million traces being produced. If you've already profiled the behavior of your application and you know most of that traffic is normal traffic that doesn't result in an error, you might only be interested in seeing a fraction of that traffic. You might want to see only like 10% of normal traces and 100% of all error traces. And that's what sampling enables you to do. When talking about sampling, there's generally two types of sampling techniques. There's head sampling and tail sampling. Head sampling means we're making sampling decisions within the application logic before traces are sent to the OpenTelemetry Collector. Using sampling policies, the application decides whether or not to select a trace for sampling at the beginning of the trace. The key thing to understand here is that the application doesn't know what will be the outcome of that trace. It could be a trace that results in an error, or it could be a normal trace, and it's possible that the application drops traces that result in an error that you would otherwise want to be able to see, and you would have wanted those traces sampled. And so this is one of the most important distinctions between head sampling and tail sampling. In head sampling, you're making a decision about the trace before having all of the information about that trace available to you. Tail sampling sends all traces to the collector, and then the OpenTelemetry Collector will make sampling decisions based off of sampling policies that are defined in the OpenTelemetry Collector's configuration. What this means is that all of the traces that are sent to the OpenTelemetry Collector, generally speaking, will be complete traces. So we'll be able to make an informed decision about whether or not to sample that trace. Let's quickly review the project structure for this demo. I created a very simple Python Flask application that simulates an order service, and it has a single endpoint. I'm also using the Splunk distribution of the OpenTelemetry Collector. And for this demo configuration, I'll be using Splunk Observability Cloud as the backend. And these are the tail sampling rules that I've defined in the collector. So we're going to capture 100% of the error traces, 100% of traces with a latency over 1.5 seconds, as well as a custom error attribute sampling policy. It captures 100% of traces with a specific error attribute that we'll take a look at. And then finally, we have probabilistic sampling of normal traces that captures 10% of all other traces. And I'll show you how I implemented these tail sampling policies in the collector configuration a little bit later. But first, let's quickly take a look at the application code. And I'm going to scroll down to our checkout endpoint. And then starting on line 74, this is where we create traffic or create traces that will trigger our sampling policies. So the first policy here is triggering a high latency sampling policy where we will force the trace to have latency over 1.5 seconds. And then if I scroll down to line 82, we have traffic being created resulting in errors. So all of the errors that get generated will be sampled, and there's a 10% chance that an error will be created. And there's really two types of errors here. So one of the errors that we're defining is a custom attribute that is specified as issue detected, and we're setting that to true. And so this attribute could be anything you want. It doesn't necessarily have to be an error attribute, but there could be some custom attribute that you always want sampled. In this case, we're considering it an error attribute. Another example of a custom attribute that we might want to always sample is if your service had VIP users or different tiers of subscribers, and you want to always track your higher tier subscribers, or even track the user journeys of predefined users that are important to track, like the CEO of your company. And then starting on line 96 is normal operation, where we're just responding to the request, and it's a successful request. Now let's take a look at the two collector configurations that we'll use in this demo. So the first configuration is no sampling with Splunk Observability Cloud as the backend. And this has pretty standard receivers, processors, and exporters defined. Now let's take a look at the configuration with tail sampling policies defined. Most of it will look the same, except if we scroll down to the processors, you'll see a tail sampling processor has been added. This decision wait statement on line 38 is actually very important, and it determines how long the collector waits for spans of a particular trace to arrive before it makes its sampling decision. So you really have to be careful and put a lot of thought into what value you put here for the decision wait statement. Imagine if you set this value to maybe like half a second and the collector cuts off traces that were not complete and just exports whatever was received, however many spans were received for a given trace. And there might have been, 3, 4, maybe 5 additional spans. And it's possible that that trace actually ended up in an error and you don't know about it, but the trace was sampled essentially prematurely. In some ways, that mimics the head sampling behavior where we're making a sampling decision without having the full context of the trace available to us. On the flip side of that, if you set this value too high, like let's say you wait an hour before making a sampling decision, then you're buffering a lot of data in memory, and you need to make sure that you have enough memory to support that wait time. But also, even if you have enough memory, but you're using like 95% of that, you're going to see, a performance hit, right? So you need to be careful about what the value is that you set for decision wait. And of course, on line 40, the number of traces that you keep in memory is somewhat related to, this decision wait statement as well. So now under the policy statement, we have an array of policies defined, starting with rule number 1, which is if there is an error status code contained within the trace, then we always sample that. In rule number 2, we're sampling traces with latency over 1.5 seconds. And then in rule number 3, we look up the value of that issue detected attribute, and we're checking if the value is true. And if it is true, then we're going to sample that trace. Okay, so this is a custom attribute that we defined. And finally, we have a probabilistic rule that will sample 10% of the remaining traces. Let's run this stack, and initially we'll run it with the no tail sampling configuration, and then we'll run it with the tail sampling policies. Now that the stack is up, I'm going to run a convenience script to switch the configuration to the no tail sampling configuration. Now with that configuration active, I'm going to generate some load on the application. And I'll specify 200 requests. Okay, and that load test completed. There were 200 total requests, and 178 were successful, 22 failed, and the error rate was 11%. Now I'm going to switch to the configuration with tail sampling policies, and we'll generate load a second time. So now let's look at Splunk Observability Cloud. We'll be able to compare both of these runs using separate service names that I've defined for each configuration. From the home page, I'm going to navigate to APM. And I already have the target environment selected, which is this tail sampling demo environment. Now, if I scroll down to this services section, I can see both of the services that I defined for each configuration. The no order service is the configuration with no tail sampling policies enabled, and then with order service is the service with tail sampling policies enabled. So if we take a look at the no order service service page, it says that it has a success rate of 89%, and we can look at the traces for this service as well. And you can immediately see all of the long duration traces listed here under the long traces section. And traces with errors are listed here on the left-hand side. Now let's switch to the order service with tail sampling configured. Again, we're getting the traces with errors as well as long duration traces. If I navigate to the overview page, notice the success rate is listed as 64%. Let's compare that with what was listed in our load generation script. The error rate listed in the load generation script is only 9%. So this doesn't align with what Splunk Observability Cloud is saying. And the reason for that is because Splunk Observability Cloud is inferring these metrics based off of only the data that's ingested, which is just the sample data. So if I navigate back to APM and then I select traces, I'll select with order service, and we only have 54 traces that were ingested, even though there were 200 requests or 200 traces that were generated from those 200 requests. And if we take a look at the service with no tail sampling configuration enabled, you can see that all 200 traces show up in Splunk Observability Cloud. And I'll navigate back to APM. And if I scroll down to where the services are listed, you can see the error rate listed for each service down here as well. So this is something that you have to consider if you're implementing tail sampling policies, is that your observability backend might try to infer metrics that will be skewed if you implement those tail sampling policies. And there are ways to mitigate this by aggregating metrics before sampling traces so that you get a more accurate data set of metrics and sending those to the observability backend. And I won't cover those techniques in this video, but be sure to subscribe and turn on notifications for the channel because I will demonstrate how to do tail sampling and also maintain accurate metrics in a future video. As you can see from this demonstration, enabling tail sampling policies is not the hard part, and you have to be thoughtful when deciding what tail sampling policies to include in your implementation, as well as what should be the values of the parameters of those tail sampling policies. That's a much more difficult decision than simply implementing and enabling tail sampling policies. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. And if you're interested in trying Splunk Observability Cloud yourself, you can navigate to this link to claim your free 14-day trial. Thanks for watching.